Hi and welcome. So here's my next project. This piece here is the rear part of a camera jib on stage. They're designed to do big sweeping camera shots. Here's a look at the jib now. So we made the parts for this guy for the handle, which haven't been installed yet. And then this mini cam used to be installed on the jib over here. And so I made that plate, didn't do a video on it, but made that plate for the camera on the jib. Now, going down the arm of the jib, this rear section, we're going to be working on this piece, which comes off. We've got to bore out this section here because over the years, this metal piece going through here has made the aluminum no longer round and it fits eccentrically. So we're going to build a bushing for that. We're going to replace this shaft. So that's how this project's going to go. So this section disassembles right here, and you basically unloosen this and the whole piece comes out. And this is a jib to do long camera moves. And so this is the rear section of the jib where all the counterweights are located, as well as all the electronics and the controls. I've got some controls down here. I brought them just to make sure that when I'm done, the parts will fit. These 3 bars here, so one bar fits underneath, and that bar is for some of the monitors on the left side. The top one is for the electronics on the right side that control the servos. And the rear one here is the counterweight. And this bar comes out and the controls are actually mounted on the bar. This one right here, that fits this bar right here, which is pretty damaged. And you will see that used to be a snug fit. And you can see it's like a BB in a box car. It is just 1/8 inch aluminum here, and it got damaged pretty well. So what I'm going to do is I'm going to drill this out, and I am going to make a bushing that goes in there with a 1-inch hole down the center. I'm going to replace this bar that's all scored up from tightening screws against it. I'm going to replace with this nitride coated bar here. This is some pretty nice stuff. I got a McMaster-Carr, pretty good. 1-inch nitride coated alloy bar, so strong, straight, ground and polished, then coated with nitride. Now it's very hard to cut, so my first goal is just going to be to cut out a piece to replace this one here. And I'm going to use an angle grinder to do that because cutting this stuff on the saw, the blade skitters off initially, which is what it's supposed to do. So that's good. They drill and tap the ends of these for these keepers just to stop stuff from falling off the ends, but they never used them on this bar. I probably reproduced that anyways, just in case. This part here, the weights don't actually hang up here. This top bar is not where the weights hang. The weights actually hang off of these 2 parts here, which go either side, and they have bearings in the top that allow the weights to swing freely and not bind up. Keeps the weight out of the way of the operator. And they have these stops, these keepers here that have a key in them, but they never used them like this because in actuality they put these parts here flush against the outside of this, and these were out here, which makes no sense because clearly this was designed to be here, but they don't use it that way. So I have some different stops that I'm going to give them. And they have this fiberboard washer that let things rotate without wearing out the aluminum. So I'm going to make a couple of those out of Delrin as well. So that's what I'm going to do. So before I try and face the end, I want to get some of this nitride out of there, and I'm going to try and get under it. You know, I think, yeah, I'm going to try the chamfer cutter and see if I can put the chamfer on the end and get under the nitride so I can just face the part that needs to be. It's a little bit around. The angle grinder had a little bit of difficulty going through it with the abrasive cutoff wheel. And it was quite impressive, really. The inside's not very hard. I was worried it's hard in both ways because it really was difficult to cut through. So this is kind of surprising me a little bit. So I popped the file on here just to round over the edges a little bit, take out any sharp points. When the file was on the nitride, it just skated, just popped, just bounced there, didn't cut at all. Turned it a little to more of an angle and it cut right in. So we're going to drill and tap this to 3/8 16 and flip it around, do the same thing, and we'll be done with this part. One side done, and I've had really poor luck with these guys giving me chatter. Like you see the chatter marks and the chamfer all the way around. Single flute ones I don't have the same problem with. I don't know exactly what the deal is. It doesn't fit deeper into the chuck than about this, so maybe it's because it's got the long shank. I don't know. I know these things kind of need rigid setups. So flip the part around. Here's the other end. They must coat these bars as an entire length pre-cut, because both ends of the bar have nitride coating over the whole end here. So they didn't cut it off after the fact. And so I took this over to the bench grinder and ground all of the nitride coating off so that I can get in there. And we're just going to drill and tap and take care of it. Let's see how we do chatter-wise with this kind of countersink. Night and day better. So to replace these nasty locking bars that go on here, I found these guys on McMaster. They're adjustable tightness on the back. You just tighten that Allen screw and you just flip these down and good to go. Considering this is a nitride coated bar, that's pretty impressive. From the factory, they would slip just a little bit. Now that I just give them a tiny snug, they're perfectly tight, easy to undo. So that's a step up. Next up, we want to make some of these guys. I'm going to make them out of this Delrin. All I had in this diameter was white. I prefer black just because it won't show the dirt as much and so it'll look nicer longer. Just going to face it off. Then we'll cut a 1-inch diameter hole down the center. And part off 4 washers. By the way, so you know to cut this, I use a positive rake aluminum insert on this, and it cuts the Delrin beautifully. Gives you a perfect finish. It's pretty amazing. Normally I'd pre-drill, but I don't think I need to, because this is Delrin. And this is a fresh drill bit, recently sharpened. Okie dokie. Handily done. Now we just need to part off a bunch of these and we should be good to go. Well, that's one. That was surprisingly easy. Yeah, I was right there. Alrighty. Well, we're done with one extra. Yeah, the finish is really fantastic on most of these. That last one's a little rough. You can tell where I had to reposition the cutter a couple times. But there we go, got our spacers. For plastics, there's this deburring tool by Shaviv that uses ceramic, and it works really well. It's kind of hard to do it in this awkward angle here, but does a great job deburring plastics. All right, so the hole I want to put through here is going to be about 1.25 inches, and I can't easily bore it because it's 3.5 inches, and I don't have a boring bar that'll fit in my boring head that is that long. Now, I could make one of those. The other option is to use an annular cutter, but the annular cutter won't go all the way through. There's only 1/8 inch thick material, but I can't reach the other side. So what I'm thinking about doing is making an extension arm for this guy so that I can plunge it straight through so that I know that the hole is in line with itself. So we're going to make an extension for this guy. Got a bar here of 1144 stress proof, and it's 1.5 inch diameter. So we're going to take this guy down and we're going to turn it into the holder. So we're going to start with the female side first and then flip it around, do the male side second. And we're going to have to drill and tap some holes on the female side for 2 3/4 inch bore down the center that has to be pretty close, and then 2 set screws at 90 degrees from each other. And at the other end, it needs to be 3/4 inch, pretty close, with some flats in it, some Weldon flats like this, that'll accept set screws from the other side. Just going to face this guy off first. Okay. Next up, we want to take the outside diameter of this and take it down to 1.25 inches. That'll give me 1/4 inch for a set screw on each side. Swapped out the insert. Now we're getting good surface finish. Kind of pressed it too hard on some harder material a while ago. Left it the worse for wear. Never used a reamer this large. 70 RPM. That went really nicely. Doesn't look like it threw a burr either. Huh. It looks like it's not a smooth finish in there, but I gotta tell you, my finger doesn't feel that. Neither does my fingernail. That's interesting, it's just appearance. The important thing is, how does this fit? Okay. That reamer might have been a tiny bit undersized. Holy cow. Wow. Rather than bore it and get a better finish, I took this die grinder with a piece of rod in it that I cut with a hacksaw, I think, way back when. And you basically just take a piece of sandpaper. This is the one that was in it, got kind of shredded, but you just run it down the split. You wind it up in the direction that it's going to turn, and then you just go back in and out, and you clean it up. Here's our fit. Couldn't ask for a better fit than that. Holy cow. No wiggle whatsoever. It was a little bit tight from the get-go, so now we're right on. All right, so we can flip it over and do the other side. Now I got this guy flipped around, and I just need to remove a bunch of material here. Just cutting the end down to 3/4 of an inch. Just take the edge off this guy a little bit. Okay, and for the fit, there we go, nice. Alrighty, so I need some flats, put some flats in here. One to get my centers or a flat spot for the drill bit to hit for the set screws, but also so that I have some datum points. So I am going to go ahead and mill some flat spots in the tops of these, not a very big one. That should be good. Now that'll let me rotate this guy. Let me just clean this up. That will let me rotate this guy 90 and have a reference point. Because I can now set this flat against here. I don't know how easy this is for you to see, but I have two flats 90 degrees apart, which I can reference against. Now on each of these flats, we need to drill and tap, 1/4 20. Now we just got to take and rotate it 90. Next up, we're going to reproduce the flats on the far side of the part here. So we're going to reproduce the flats down here. Since this is not terribly well supported, we're going to take fairly small passes. And we're there. Now I just need to rotate 90 and do it again. Side 2. Here's 20 thousandths. And that's it. Just got to deburr it and we're done. All right, so that finishes the extension. Here it is. There's the extension looking kind of good. So this guy fits in here like this and gets tightened down like so. There we go. I made it a really snug fit, and this will give me greater than the 3.5 inches I need to penetrate. Hopefully you can see that. There you go. So this is an R8 arbor, and there's my extension. It's smaller diameter than the cutter. which means it won't be useful for smaller cutters unless you just need to reach in through a bigger hole, but it will work for what I need to do here, so that's good.